Okay, let's move on to question number 21. You are presenting a multi-cloud solution to an Oracle Cloud Infrastructure customer. Their goal is to mirror their Microsoft Azure environment on OCI. They are aware that there are multiple different ways to achieve the goal, including deploying a dedicated interconnect between OCI and Azure, as well as traditional IPsec and VPN solutions. During your presentation, which two statements would you use to describe the OCI and Azure interconnect? Okay, let's look into the options. Option A, it always provides lower cost. Dedicated interconnect often cost more than VPNs due to premium bandwidth and infrastructure. So option A not a good choice. Moving on to option number B, it always provides higher availability. Availability depends on region and configuration, not guaranteed to be higher than VPN. So option B again a wrong choice. Moving on to option number C, it is likely to provide less packet loss. Private internet bypass public internet, reducing congestion and packet loss. So option C might be a potential answer. Moving on to option number D, it is likely to provide low latency. Direct routing between OCI and Azure region minimize hope and latency. Option D also looking a good answer. So option C and D will be the correct answer. Okay, let's look into question number 22. A consulting company that employ Oracle Cloud Infrastructure Architecture has successfully completed resource migration from Microsoft Azure to OCI and no longer requires the Oracle Fast Connect circuit to Azure. The project manager has asked you to delete all resources involved in the cross-cloud connectivity. From the Azure side, you delete the resource group. After a while, you notice that all Azure resources have been deleted except the Azure Express Route circuit. What could be the reason for this issue? Okay, let's look into the options. Option A, you need to remove the Azure Express Route partner service key from the Oracle Fast Connect circuit, and then you can delete the Express Route virtual circuit. The Express Route circuit remains active until the partner service key is removed from the OCI Fast Connect. So option A looking a good answer. Moving on to option number B. Your bill from a OCI side needs to be paid in full before you can remove the Azure Express Route circuit. Billing status does not block resources deletion in Azure. So option B not a good answer. Moving on to option number C. You need to first delete the Oracle Fast Connect circuit for the Express Route circuit to be decommissioned, and then you can delete the Express Route virtual circuit. Deletion sequence depends on unlocking via partner key, not just removing OCI circuits. So option C again a wrong choice. Moving on to option number D, you need to remove all routes that point to the cross cloud connection on both OCI and Azure before you can delete the circuit. Root cleanup is good practice but not mandatory for circuit deletion. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 23. Your sales team is dealing with a potential multinational customer from South Africa that wants to migrate their existing three-tier architecture from on-premises to OCI Johannesburg region. They intended to use their own /24 IPv4 CIDR block. They own several awarded to them by different regional internet registry, which three RRIs are supported by OCI. Okay, let's look into the options. Okay, option A, African Network Information Center. OCI supports IP ranges allocated by AFRINIC related to South African customers. So option A looking a good answer. Moving on to option number B, RISOC's IP address European Network Coordination Center. RIPE NCC issued IPsec are accepted by OCI for BYOIPs. So option B again looking a good answer. Moving on to option number C, Latin America and Caribbean Network Information Center. OCI does not currently support IP blocks from LACNICs. So option C not a good answer. Moving on to option number D, American Registry for Internet Numbers. ARINs issued IPs are supported for BYOIPs in OCIs. So option D again a good answer. So option A, B and D will be the correct choice. Okay, let's look into question number 24. Bringing an IPv4 6 prefix to Oracle Cloud Infrastructure involves several steps to ensure the proper validation and import of the prefix, which step is not part of this process. Okay, let's look into the options. A. Request import in OCI within your OCI tenancy request to import the IPv4. Okay, let's look into question number 24. Bringing an IPv4 prefix in Oracle Cloud Infrastructure involves several steps to ensure the proper validation and import of the prefix, which step is not part of the process. Okay, let's look into the options. Option A. Request import in OCI within your OCI tenancy request to import the IPv6 prefix that you own. Requesting import is an OCI initiates the BYOIP-v6 process by registering the prefix within your tenancy. So option A looking a good answer. Okay, let's look into question number 24. Bringing an IPv6 prefix to Oracle Cloud Infrastructure involves several steps to ensure the proper validation and import the prefix. Which step is not part of this process? Okay, let's look into the options. Option A. Request import in OCI within your OCI tenancy request to import the IPv6 prefix that you own. Requesting import in OCI initiate the BYOIPv6 process by registering the prefix within your tenancy. So option is not a good answer. Moving on to option number B. Create route origin authorization in the ROA provides the Oracle BGP autonomous system number specific to your region. Creating a ROA authorization Oracle BGP ASN to advertise your IPv6 prefix validating ownership for import. So option A, option B not a good answer. Moving on to option number C. Prepare the IPv6 prefix. Ensure that you own the PV6 prefix you want to import and that it meets the necessary criteria. Preparing the IPv6 prefix ensure you own it and that it meet OCI formalities and eligibility criteria for import. So option C again a wrong choice. Moving on to option number D. Update your domain registry, add the verification token and detail about the IPv6 prefix to your own DNR service. DNR is unrelated to IPv6 prefix validation. Registry updates happen via RIR. So option D will be the correct choice. Okay, let's look into question number 25. You are a security administration task with granting temporary access to a developer for troubleshooting a production issue on a virtual machine in Oracle Cloud Infrastructure. Which feature of the Oracle Bastion allows you to provide the temporary access securely? Okay, let's look into the options. Bastion MFA authentication. MFA authentication login security but does not control session during or access scope. So option A not a good answer. Moving on to option number B. Bastion Imperial Access. Bastion Imperial Access enables secure time-bound SSH session to private instance without persistent credential. So option B looking a good answer. Moving on to option number C. Bastion Role-based access control. RBAC governs permission but does not provide session level access control. So option C not a good answer. Moving on to option number D. Bastion Session Recording. Session recording is for auditing, not granting temporary access. So option D not a good answer. So option B would be the correct one. Okay, let's look into question number 26. You have an Oracle Enterprise Unix base instance running in a private subnet. Which three actions must you perform to enable connectivity to this instance from your IP address using OCI Bastion services? Okay, let's look into the options. Option A. Allow SSH for the private subnet from the Bastion private endpoint IP address. Allowing SSH from the Bastion private endpoint IP ensure the Bastion service can reach the target VM within the private subnet. So option A looking a good answer. Moving on to option number B. Add a rule in the private subnet security list to allow ingress from your IP address. Allowing ingress from your IP is unnecessary since Bastion handles the connectivity connection and your IP does not directly access the private subnet. So option B not a good answer. Moving on to option number C, create a managed SSH session to the target VM with your public key. Creating a managed SSH session, use Bastion plugin to securely connect to the target VM with your public key. So option C again a good answer. Moving on to option number D, add your IP address in the Bastion CIDR block allow list. Adding your IP address in the Bastion CIDR allow list ensure only trusted source can initiate secure access session. So option A, C and D will be the correct choice. Okay, let's look into question number 27. Which statement is true about the default IPv6 security list in your IPv6 enabled VCN? Okay, let's look into the options. Option A, there are default rules that allow ICMPv6 traffic type 2 code 0 from source 0 and any source port below 32768. OCI includes a default rule allowing ICMPv6 type 2 code 0 from any IPv6 sources. So option A no looking a good answer. Moving on to option number B, there is a default rule that allows IPv6 CP traffics on destination port 22 from source and any source port. SSH is not allowed by default in IPv6 security list. It must be added manually. So option B not a good answer. Moving on to option number C. There is a default rule that allows IPv6 TCP traffic on destination port 3389 from source 0 and any source port. RDP is not included in default IPv6 security list either. So option C again a wrong choice. So option A will be the correct one. Okay, let's look into question number 28. You have deployed a workload both on premises and in Oracle Cloud Infrastructure region. The host computer in your on-premises network is not able to connect with the application deployed in OCI. You have heard about an OCI service network path analyzer in the network command center, which is used to identify and resolve this kind of issues faster. Which three statements are true about the OCI network path analyzer? Okay, let's look into the options. Option A, it is capable for both indirectional and bidirectional path analysis between a pair of endpoint. OCI Network Path Analyzer supports both forward and return path analysis between endpoints. So option A looking a good answer. Moving on to option number B. It is a free service that comes with the overhead of transmitting actual application traffic to troubleshoot reachability issues. Simulating path analysis avoid transmitting actual application traffic, enabling safe and efficient troubleshooting. So option B, we are not looking for this answer. Moving on to option number C. It is a tool to perform on-demand validation of the logical network path to match a desired intent. Perform on-demand validation to confirm the logical path and lines in intended connectivity design. So option C looking a good answer. Moving on to option number D. It can troubleshoot reachability issues caused by misconfiguration and determine the reason for an outage between two endpoints. Diagnosis outage by pinpointing my misconfiguration is routing security rules or gateway setup between endpoints. So option A, C and D will be the correct choice. Okay, let's look into the question number 29. Your organization has a public facing load balancer with a web server back end servicing a public accessible HTTP web application. You must identify any potential anomalies and malicious behavior to detect if any web shell is being uploaded. You decided to mirror all HTTP traffics in both directional by using the Oracle Cloud Infrastructure Services Virtual Test Access Point. You have configured all the required routes and security list to mirror the traffic for analysis. In which three ways you can configure VTAPs? Okay, let's look into the options. Okay, let's look into the options. Configure the VTAP source as network load balancer and the VTAP destination as a load balancer listening on UDP port 4789. VTAP destination must be a network load balancer, not regular load balancer. So option A not a good choice. Moving on to option number B, create a capture filter to include ingress and ingress rules with destination port as 80. Capturing filter targeting destination port 80 accurately mirrors HTTP's traffic in both ingress and egress directions. So option B looking a good answer. Moving on to option number C, configure the VTAP source as the load balancer and the VTAP destination as load balancer listening on UDP port 478. Mirroring traffic from the load balancer to the network load balancer on UDP port 4789 enables scalable packet capture for analysis. So option C looking a good answer. Moving on to option number D, configure the VTAP sources as the backend web server and the VTAP destination as the load balancer listening on TCP port 4789. Mirroring traffic from the web server to a destination listening on TCP port 4789 enables deep inspection of application level anomalies. So option B, C and D will be the correct choice. Okay, let's look into question number 30. You receive a request from one of your Oracle Cloud Infrastructure customers for all virtual cloud networks, internet traffic to be sent on-premises using the Fast Connect link and from on-premises to the internet. In which two ways you can achieve this goal? Okay, let's look into the options. Option A, create a default route with the DRG as the next hop in the route tables associated with the VCN subnet. Default route to the DRG enables all outbound VCN traffics to be forwarded to on-premises via Fast Connect. So option A looking a good answer. Moving on to option number B, create default route with the internet gateway as the next hop in the route table associated with the VCN subnets. Default route in the internet gateway bypasses on-premises routing and send traffic directly to the public internet. So option B looking a good answer. Option Okay, let's look into question number 30. You receive a request from one of your Oracle Cloud Infrastructure customers for all virtual cloud networks, internet traffics to be sent on-premises using the Fast Connect link and from on-premises to the internet. In which two ways you can achieve this goal? Okay, let's look into the options. Option A, create default route with the DRG as the next hop in the route tables associated with the VCN subnets. Default route to the DRG enables all outbound VCN traffics to be forwarded to on-premises via Fast Connect. So option A looking a good answer. Moving on to option number B, create default route with the internet gateway as the next hop in the route table associated with the VCN subnets. Default route to the internet gateway bypasses on-premises routing and send traffic directly to the public internet. So option B not a good answer. Moving on to option number C, ask the customer to send a default route via BGP and import it in the DRG VCN attachment route tables. Importing the default route advertised via BGP enables OCI to forward all outbound traffics to on-premises through the DRG. So option C looking a good answer too. Moving on to option number D, ask the customer to send specific IP prefix for internet destination via BGP and import them in the DRG VCN attachment route tables. Partial prefix won't capture all internet traffics. Default route is required for full redirection. So option D again a wrong choice. So option A and C will be the correct one. Okay, let's look into question number 31. As a consultant working for an Oracle partner, you are architecting a nationwide connectivity solution on Oracle Cloud Infrastructure for a startup. They currently have two different tenancy for the West Coast and the East Coast of the United States, locating in the San Jose CA and Ashburn via BA region. The customers has 5 virtual cloud networks in each region. The primary option being evaluated by the customer is to deploy a dynamic routing gateway and connect the VCNs through the construct. Which two statements are true about the proper architecture for this customer? Okay, let's look at the options. Option A, your global connectivity strategy must be consistent across the board. So if you use DRG to use connected their San Jose and Ashburn footprint, you cannot use LGPs for connectivity between their VCNs in each regions. DRG and LPG can coexist. LPGs are valid for intra-region VCN peering. So option A not a good choice. Moving on to option number B, the interconnecting the two tenancy in each region using enhanced DRGs. The architecture still needs to manually configure the IAM policies. Cross-tenancy RPCs requires explicit IAM policies to authorize peering between DRGs. So option B looking a good answer. Moving on to option number D, option number C. To have a proper architecture, you will need a DRG in each region. The two DRGs can connect to each other using their RPCs. The VCNs on each side must be in the same tenancy of have the same administration team. VCNs can reside in different tenancy admin team alignments in not is not a technical requirement. So option C not a good answer. Moving on to option number D. To have a proper architecture, you will need a DRG in each region. These two DRGs can connect to each other using their RPCs. The VCNs can be located in different tenancy. RPCs between DRGs support cross-region and cross-tenancy connectivity. So option B and D will be the correct choice. Okay, let's look into question number 32. To implement your DNS strategy, you create a DNS private view in Oracle Cloud Infrastructure. You also need your own DNS zone, example.com, inside custom view. Next to you create an A record for web.example.com. When you try to resolve web.example.com from your compute instance deploys inside of your virtual cloud network, you notice that the DNS resolution fails. Which step could you been missing during your setup processes? Okay, let's look into the options. Option A, zoneexample.com needs correct NS records in the register. Register settings apply to public zones, not private DNS in OCI. So option A not a good answer. Moving on to option number B, the private zone examples.com must be also added to the VCN default private view. Custom zones must be resolved via associated custom views, not default views. So option B again a wrong choice. Moving on to option number C, the VCN resolver needs a forwarding rule for the zone example.com. Forwarding rules are used for conditional DNS forwarding, not resolving zones within custom views. So option C again a wrong choice. So let's look into option number D. The private view need to be associated with the VCN DNS resolver. VCN DNS resolution fail unless the custom private view is explicitly linked to the VCN's DNS resolver. So option D will be the correct choice. You have deployed a virtual cloud. Okay, let's look into question number 33. You have deployed a virtual cloud network in an Oracle Cloud Infrastructure Ashburn region for production workload. You have also deployed another VCN in the Phoenix region for a disaster. You have created a network connection between the two VCNs by using the remote peering connection service in the dynamic routing gateway. After you finish the configuration of routing and security policies, you observe the pinging to the IPs works, but you are unable to resolve host names from the other region. Which is the best way to enable DNS resolution between the two regions? Okay, let's look into the options. Option A, go to regional DNS setting and enable cross-region resolution. OCI does not offer a global toggle for DNS resolution across region. So option A, not a good answer. Moving on to option number B, go to one region and export the DNS zone to the VCN. Go to the other region and import the zone. Repeat the steps in the other direction. Manual zone replication does not support dynamic resolution for scale. Okay, so option B, not a good answer. Moving on to option number C, create manual entries in the host file for each compute for system deployed in the other region. Static entries are error prone and unimaginably large for the deployment. So option C, again a wrong choice. Moving on to option number D, deploy two DNS resolver endpoints, one forwarding and one listening in each VCN. Create DNS forwarding rules for each VCN to the other VCN listeners for the remote VCN and DNS zone. Deploying forwarding and listening resolvers endpoints with DNS rules enabling dynamic cross-region hostname resolution between VCNs. So option D will be the correct choice. Okay, let's look into question number 34. Which statement is true about Oracle Cloud Infrastructure Private Endpoint? Okay, let's look into the options. Option E, destination service IP address is a private IP address within the customer subnets. The private endpoint uses private IPs in the customer subnets, but the destination service IP is not within the subnet. So option E, not a good answer. Moving on to option number B, they provide access to all Oracle services or just object storage. Private endpoint supports over 25 OCI services, not limited to object storage. So option B, not a good choice. Moving on to option number C, the customers can initiate a connection to the service, but a service can't initiate a connection to the consumer private network. OCI private endpoints allow only customer initiating traffic. Service cannot initiate connection back to the consumer network. So option C will be the correct choice. Okay, let's look into question number 35. As an Oracle Cloud Infrastructure consultant working for an Oracle partner, you are presenting the OCI Azure Interconnect to a customer. If the customer wants to deploy the interconnect in the London region between the Microsoft Azure and OCI footprints, which aspect would they have to manage by themselves? Okay, let's look into the options. Option E, cross connection between Microsoft and OCI routers used by customers through an LOA process. The interconnect is pre-established by Oracle and Microsoft. No LOA or physical setup is required by the customer. So option is not a good answer. Moving on to option number B, encryption of data between the two public clouds. Encryption between OCI and Azure must be configured by the customers to meet specific compliance or data protection requirements. So option B looking a good answer. Moving on to option number C, any additional redundancies between the Microsoft and OCI routes. The interconnect includes built-in dual circuit redundancy. Additionally, route level redundancy is optional, not mandatory. So option C again a wrong choice. So option B will be the correct. Okay, let's look into question number 36. You are presenting Oracle Cloud Infrastructure. Okay, let's look into question number 36. You are presenting Oracle Cloud Infrastructure databases to an existing Microsoft Azure customer with a small OCI compute footprint. They are interested in multi-cloud architecture and have been evaluating OCIs and Azure Interconnect as well as Oracle Database Services for Azure solution for a few weeks now. The customers want full control over the routing using BGP between the two cloud providers. Okay, let's look into the options. Option A, ODSA, because it offers full control over the routing process with similar availability as the interconnect services. ODSA is an Oracle managed and does not expose full BGP routing control to the customer. So option is not a good answer. Moving on to option number B, interconnect, because it's offer full control over the routing process with similar availability as ODSA. OCI Azure Interconnect supports customer managed BGP routing and offers availability comparable to ODSA for database access. So option B looking a good answer. Moving on to option number C, Interconnect, because it is offer full control over the routing process as well as higher availability. While Interconnect is high available, ODSA also leverage the same backbone, making availability comparable. So option C not a good answer. Moving on to option number D, ODSA, because it offers all full control over the routing process as well as higher availability. ODSA abstract routing and does not offers high availability than the interconnect. So option D again a wrong choice. So option B will be the correct one. Okay, let's look into question number 37. Which three types of traffic is core Oracle Cloud Infrastructure Services hosted on link local IP addresses do not appear in flow logs? Okay, let's look into the options. Option A, TCP. TCP is IP based and typically appears in flow logs unless explicitly filtered. So option A not a good answer. Moving on to option number B, IPv6 slash ICMP. ICMPv6 traffic to local link infrastructure services is excluded from flow logs. So option B looking a good answer. Moving on to option number C, ARP. ARP operates at layer 2 and is not captured in IP based flow logs. So option C looking a good answer too. Moving on to option number D, DHCP uses broadcast and link local IPs which are excluded from flow logs. So option B, C and D will be the correct choice. Okay, let's look into question number 38. You are administrator responsible for monitoring and troubleshooting network activities in your Oracle Cloud Infrastructure environment. You have enabled virtual cloud networks, flow logs, and now needs to investigate a specific network flow. The flow logs data for the connection is as follow. Based on this flow log data, which you can infer about the network flow. Okay, let's look into the options. Option E, the connection was rejected by from 172.21.2.185 to 129.146.13.236 over TCP port 443. The data transfer was 1515 bytes separated spread across 19 packets. The flow log shows the connection was accepted, not rejected, so option A misinterpret the log status. So option A not a good answer. Moving on to option number B. The connection was initiated from 129.146.13.236 to 172.21.2.185 over TCP port 443. The data transferred was 5548 bytes spread across 19 packets. The connection was initiated, uh, and the source and the destination was revised 172.21.2.185 initiated the connection, not 129.146.13.236. So option B again a wrong choice. Moving on to option number C. The connection was initiated from 172.21.2.185 to 129.146.13. The flow logs confirm accepted TCP connection from 172.21.2.185 to 129.146.13.236 on port 443 with 10,515 bytes spread over 19 packets. So option C will be the correct choice. Okay, let's look into question number 39. Which set of health checks does the Oracle Cloud Network Load Balancer support to monitor the backend instance? Okay, let's look into the options. Option E, ICMPs dash HTTPs dash and SSL. ICMP and SSLs are not supported health check protocols for OCI Network Load Balancer. So option E not a good answer. Moving on to option number B, TCP, UDP, HTTPs and HTTPs. OCI Network Load Balancer support these four protocols for health check. So option B looking a good answer. Moving on to option number C, UDP, ICMP, and TCP. ICMP is not supported protocol for health checks in OCI network load balancer. So option C not a good answer. So option B will be the correct choice. Okay, let's look into question number 40. Your company on-premises environment is connected to Oracle Cloud Infrastructure using Fast Connect private peering. You have a DNS server running on your on-premises Active Directional server and your application instance only in the OCI environment to be able to query names there. The instance must not be direct access to the on-premises DNS service. How do you achieve this? Okay, let's look into the options. Option A, create a listening endpoint and rule that has a condition set to the CIDR of your subnet. Listening endpoint receive DNS queries, they don't forward them to on-premises servers. So option A not a good answer. Moving on to option number B, create a forwarding endpoint and rule that has a condition set to the CIDR of application subnet. Using the application subnet, CIDR restricted DNS queries forwarding to those only instance, ensuring control access to the on-premises servers without direct access. So option we're looking a good answer. Moving on to option number C, create a forwarding endpoint and a rule that has a condition set to the CIDR of your VCN. Using a VCN, CIDR allows all subnet to forward DNS queries, not just the targeted application subnet. So option C again a wrong choice. So option B will be the correct one. Okay, let's look into question number 41. A global company is migrating its application to Oracle Cloud Infrastructure. The company has over 15 business units. Each business unit design and maintain applications that are hosted in its own OCI tenancy in separate application virtual cloud networks. In the same OCI region, each business unit applications are designed to get data from centralized shared services VCNs. The company wants the network connectivity architecture to provide granular security controls. The architecture must also be able to scale as more business units may be added in future. Which solution meets these requirements in the most scalable manner? Okay, let's look into the options. Create VCN peering connection between the central shared service VCN and each application VCN is each business unit OCI tenancy by using a local peering gateway in the shared service VCN for each business unit. Managing multiple LPGs across tenancy becomes complex and less scalable for business units to grow. So option is not a good answer. Moving on to option number B, create a dynamic routing gateway. Create an IPsec attachment to each application VCN. Create a VCN connection for each VCN to shared service VCN. Provides full mesh control connection among all the VCNs. Traffic will be encrypted endpoint to end from the application to the shared service VCN. Full mesh VPN introduce operational overhead and lacks centralized control and scalability. So option B again a wrong choice. Moving on to option number C. Create a dynamic routing gateway. Create a cross-tenancy VCN attachment to each application VCN. Modify the routing tables for each attachment to import the shared service VCN. DRG attachment across tenancy allows scalable centralized routing and fine-grained security control. So option C looking a good answer. So option C will be the correct choice.